Hello my friends, welcome to another video. In this video, we will be talking about the extrema of a multivariable function. So basically, if you've taken calculus BC or AB, you may have done certain graphs where you take the extrema, whether it's a maximum or a minimum or relative, absolute, whatever. For multivariable calculus, we have 3D graphs and we find extrema, be it local or absolute, or saddle points in various ways. Take this chart for example. This shows you how in multivariable calculus you have local minimums, local maximums, and of course saddle points where it is neither a minimum or a maximum. And you can see how to calculate these by the end of this video. So let's get right into it. Let's say you have f x y, which is just z, equals x squared minus y squared. To find the extrema of this graph, you will need to do a few things. Call the method GH0, gradient Hessian matrix 0. So here's the first step. We find the gradient. So fxy, that's just z. So the gradient of z is the partial derivative in terms of a vector. So it will be I, j, and I equals the partial uh, differential of this function by x, and j equals the partial differential of y in this function. If you don't know how to do partial differentiation, then please watch my last video on it and come back to this one. So let's look at these differentials here. Obviously, the partial differentiation is simply 2x and 2y here, negative 2y. So we have this gradient which we'll now set equal to 0. That means if we set each of these equal to 0, then both x and y will become 0. Now let's input this into a Hessian matrix. This is the next step. So this will be fxx, fyy, and of course fxy and fyx, which should be the same value, these two. And then you need to take the discriminant, which of course is just 0 in this case because of the formula that you can use, AD minus BC, where the letters each refer to A, B, C, D. So once you use that, you have 0. And when you have 0 as your output here, you just need to compare this output here to 0. If it is above 0, it is a minimum. If it is below 0, it is a maximum. And if it is 0, then we know that the inflection point we get, 0, 0, is a saddle point. Thank you for tuning into this video. I'll see you in the next one.